Assalamualaikum and hi everyone. Today we will continue on finding Fourier series expansion. So what is Fourier series? So a Fourier series is an expansion of a periodic function fx in terms of an infinite sum of cosine or sine. So in other words, any periodic function can be resolved as a summation of constant value cosine and sine function. So for example, in this graph, rather than we treat this graph as a compilation of many functions, so we can represent it as one series that represents all functions along the graph. So the series is in the waveforms of sine or cosine, but as the precision is higher, the smallest the wave it becomes until it almost similar to the original function. So let's see what is the definition of Fourier series. So let fx be a function defined in the interval from negative L to L. Okay, and fx be a periodic with period 2L. So we have fx equal to fx plus 2L. So the Fourier series is given by this formula. Okay, so in this formula we have the coefficient of A0, AN and Pn. So A0 is given by this formula, AN, and we also have the formula for Pn. So when we substitute all the value, then we put back into the Fourier series. This is how we make our Fourier series. Okay, so this is an example of Fourier series question where we need to find the Fourier series based on the piecewise function here. Okay, but before we proceed to the Fourier series expansion, let's try to get some formula, okay, in order for us to use this one when we solve the Fourier series. Okay, so before this we have learned that sine negative x is equal to negative sine x. Okay, and also we learn about cos negative x is equal to cos x. Okay, this one we have proved that this based on some values and we get this formula. Okay, so how about if we want to find sine and pi? Can we summarize it into any form? Okay, so what does it mean by n? So n in this value here is integer, positive integer, where we have 1, 2, 3, and so on. It cannot be a decimal point, it cannot be a fraction, it's just an integer, Okay, so what if we try to substitute n equal to 1? So we will get sine n equal to 1, so sine pi. Okay, when we use calculator for sine 180, we will get 0. So how about n equal to 2? So we have sine 2 pi. So calculator will give 0 also. Okay, so how about if I try for n equal to 100? Okay, if we use calculator 100 pi, it will also get 0. So what can we conclude based on this form? So we can get sine n pi is equal to 0 for all value of n. Okay, but remember the n here must be positive integer. Okay, next we go to the cos n pi formula. Cos n pi formula. Okay, so same, n is a positive integer. So let's try with n equal to 1 first. So we have cos pi. Okay, if you use calculator cos 180, we will get negative 1. Okay, how about n equal to 2? So we will get cos 2 pi equal to 1. Okay, n equal to 3, cos 3 pi equal to negative 1. Okay, n equal to 4, cos 4 pi equal to 1. So what is the pattern of this one? Okay, so we can conclude that cos n pi is equal to, it is a rotation of negative 1, 1, negative 1, 1. So it is the formula -1 power n. So when n is odd number, we will get negative. When n is even number, we will get positive 1. Okay, so we have two formula here, which is sine n pi equal to 0, and we also have cos n pi equal to -1 power n. Okay, but remember, if we have sine n pi over 2, okay, it does not equal to 0 because n over 2 is not will become positive integer. It will become a fraction. Okay, let's try to solve this Fourier series. So before we proceed to the Fourier series expansion, let's try to sketch the graph first. Maybe we can learn something from the graph here. So in this graph, we have x and fx. Okay, and there are two functions here, fx equal to 1 and fx equal to 3. So we plot first for the fx equal to 1. So for this function, it occurs from -1 until 0. So for the unit for x is about 1 unit. Okay, so I plot the axis first. Okay, so the unit for x is about 1 unit. Okay, meanwhile for the fx, okay, so fx we have 1 and 3, so 1 unit also. Okay, so for the first graph, we have from -1 until 0, we have fx equal to 1. So it's just a straight line along the line y equal to 1. Okay, so for the another function, we have from 0 to 1, we have fx equal to 3. So we plot a straight line also, okay, from 0 to 1 for the function of fx equal to 3. So just sketch within the limit given. Okay, so here we also have fx plus 2. So what does 2 here means? It is actually a cycle of a period. Okay, so if we observe from the both function that we sketched earlier, so the length of both functions are about, from -1 to 1, we have about 2 units. Okay, it is about 2 units. So it means that this is the cycle of the period that the fx plus 2. Okay, it is similar to the fx plus 2. So means that we just have to copy that one, okay, because it is already in the cycle of 2 period. Okay, so if I copy that one, so we will have the same length, okay, and then from 2 to 3 we have this function. Okay, if I plot this one, okay, the same goes to the backward here. So we have up here, okay, and down here we also have this point. Okay, so it should be like this. Okay, means that there are after 2 periods, okay, and we will get the same function back. Okay, so let's go to the solution. Okay, so we have, in this solution we have L. So what does it mean by L? So in the previous formula, we can obtain L from fx plus 2L. This is the general form for a cycle of period is given by 2L here. So based on this question, we have fx plus 2. Okay, fx plus 2. So to get to L, we can compare both and we get to L equal to 2. So L equal to 1. Okay, so after we get L equal to 1, we can substitute into the formula. So A naught equal to 1 over L equal to 1. So negative L to L, we have -1 until 1 fx dx. Okay, so what does the integration here means? So it means that we need to integrate the function from -1 to 1. So if we look at the graph here, from -1 until 1, there are two functions, first and second. So we need to split the function first in order for us to integrate that one. So if I split, so first we have the first function is from -1, we put the lower limit, and here is the upper limit from -1 until 0. Okay, from -1 until 0, we have the function is 1 dx plus, okay, next we start from 0, okay, from 0 until 1. Okay, the limit of x here from 0 until 1, we have the function is equal to 3 dx. So next, so we get x -1 until 0 plus 3x from 0 to 1. Okay, so no need to put plus c because this is a definite integral. Okay, so just substitute -1 and 0 into x. So we have 0 minus lower limit, so we substitute with -1. Okay, then for x, next for 3x we have 3, 1 minus 3, 0. So this is so we get 1 plus 3 minus 0, so we get 3, so equal to 4 for a naught. Okay, next we go to an. Okay, next we find an. Okay, so an equal to 1 over 1, integrate from -1 to 1, the same thing. Okay, just that the difference is we have cosine here of what L equal to 1 dx. Okay, so since we have two functions from -1 to 1, we split. So we have -1 until 0. So fx substitute with 1. So we have cos n pi x. Okay, dx plus from 0 to 1, we have function is 3. So the formula is cos n pi x dx. Right, then we have integrate cos, we will get sine n pi x over, okay, over, so we put the constant. So our constant here is n pi. So from -1 until 0 plus integrate 3 cosine n pi x, so we get 3 sine n pi x. Make sure to put over for all function, over n pi. Okay, we just take the constant inside the sine term, and from 0 until 1. Let's substitute. Okay, we cannot simplify n pi here and n pi inside the sine. Okay, so just remain like that. So we substitute 0 and -1 into x term. Okay, x term. So 1 over n pi, I bring out this one. So we have sine n pi 0 minus sine n pi -1. Okay, then plus 3 over n pi, constant bring out, so just substitute into x. So we have sine n pi 1 minus sine 0. Okay, since at 0 we get all 0. So we have sine 0, n pi 0 is 0. So sine 0 is 0. So this one we get negative sine minus n pi. Okay. Plus 3 over n pi sine n pi. Okay, I copy this one first. Minus sine 0. Sine 0 is equal to 0. So we have only 0. Okay, so based on the formula here, okay, we have this formula. So we use that. So we get sine minus m pi, or sine m pi will become 0. This one also 0. So the answer will be 0 for an. Okay, next we find for bn. So bn equal to 1 over 1 also. 1 fx sine n by x over 1. Okay, so define the function occur from -1 to 1. So we have -1 until 0. So the function is 1 sine n by x dx plus another function occur from 0 to 1. So we have 3 sine n by x dx. Okay, so the answer will be sine, okay, we get negative over n pi. Okay, integrate 3 sine n pi x, we will get negative 3 cos n pi x over all the function, then put n pi. Okay, from 0 to 1. Then substitute. Okay, we just bring -1 over n pi. Okay, so just substitute 0 and -1 into x. Cos n pi 0 minus cos n pi -1. Okay, plus, oh sorry, minus. Okay, because we have minus term. So just bring out first 3 over n pi. So we have inside here cos n pi 1 minus cos n pi 0. Okay, so simplify, we get -1 over n pi cos 0 minus cos minus m pi. Okay, so since we have cos minus m pi, we refer to the cos minus x. Okay, I put this one first. Minus m pi minus 3 over n pi. So we have cos n pi minus cos 0. Okay. Okay, if you refer to the table, okay, formula here, we have cos 0 equal to 1, cos 0 equal to 1, cos m pi equal to -1 power n. Cos minus m pi here, we can refer to cos here. So means cos, if we get minus m pi, it is equal to cos n pi. Okay, so cos m pi is equal to -1 power n. So means that we also get for this one -1 power n. So if we continue, we will get -1 over n pi. Okay, so it will become 1 minus -1 power n. Okay, minus 3 over n pi. Then we will get -1 power n minus 1. Okay. Okay, factorize all the value here. We factorize in terms of -1 over n pi. So we will get 1 minus -1 power n. Okay, plus 3 minus 1 power n. Okay, minus 3. Okay, then we will get -1 over n pi. Okay, 1 minus 3 is -2. Then minus 1 plus 3 minus 1. So we get plus 2 minus 1 power n. Okay, here we have A naught, A and B and, where these are the coefficient for the Fourier series that we have calculated earlier. So I just copy back. Next, we want to substitute into our Fourier series. Okay, so this is the formula. So we just need to substitute. So let's proceed. So fx equal to 4 over 2 plus summation from n equal to 1 until infinity. So we have an cos n pi x over L. So since an equal to 0, just multiply by cos, we will get 0. So just ignore this one. So we just substitute for bn. So for bn we have minus 1 over n pi. Okay, 1 over n pi. So we have negative 2 plus 2 minus 1 power n. Okay, finish for bn. Then substitute for sin n pi x over L. Sin n pi x over L equal to 1. Okay, so substitute this one. Next, so this is our Fourier series. Fourier series. Okay, but since we want to find the Fourier series expansion, we need to open. Okay, simplify the term of summation here. Summation from n equal to 1 until infinity. Okay, so let's try to expand this one. 4 divided by 2, we get 2. Okay, plus. Okay, I put in bracket first. For the summation here, we have from n equal to 1 until infinity. So we start with n equal to 1 first. Okay, so let's start minus 1 over n equal to 1. So we have 1 pi. So we have negative 2 plus 2 minus 1 power 1. Okay, sin pi x. Okay, next continue with n equal to 2. Okay, it should be plus, but since we have negative, okay, as at the coefficient here, so we just put negative. Plus minus is minus. Okay, so 1 over n, so 2 pi, n equal to 2. Substitute all value except for n, we just substitute with 2. Okay, sin 2 pi x. Okay, so next substitute with n equal to 3. Okay, plus n equal to 3. So since we have here negative, just start with negative 1 over 3 pi. Okay, minus 2 plus 2 minus 1, 3. So we have sin 3 pi x. Until when? Just put dot dot dot. Okay, we stop until 3, then we finish. Okay, simplify this one. We get 2. Okay, so open the bracket here, we have plus minus. Okay, so we get minus here. Okay, negative 2. Okay, we simplify the bracket first. So negative 2 plus minus, so we get minus 2. So simplify this one, we get minus 4. Okay, here we have negative 1 power 2 is equal to 1. Okay, so negative 2 plus 2 multiplied by 1, we will get 0. Okay, so negative 1 power 3 is negative 1 multiplied by 2, we get negative 2. So negative 2 minus 2, we get minus 4. Right? So simplify, open the bracket all here. So we have minus minus positive. So we get positive back. Okay, this is minus, positive. So we have 4 over pi sin pi x. You cannot simplify pi x because x can be any kind of value. So not all value can become 0 for sin pi x. Okay, so 0 here, second coefficient here, we have 0 multiplied by 1 over 2 pi, 0. Okay, so all this will become 0. So next we continue on this one. We have this is negative 4 multiplied by negative, so we get positive back. So we have 4 over 3 pi sine 3 pi x plus dot dot dot. Okay, so this is our Fourier series expansion. Okay, where we do not have anymore the term of summation because we have extend by substitute by n equal to 1, n equal to 2, n equal to 3, and so on. Okay, so these are the summary that we have learned from this video, where we have the Fourier series here. Okay, for the Fourier series we have the coefficient of n0, an, and bn, and also we have l we get from the x plus, the general form is x plus 2l. Okay, then we can obtain l from the cycle of period here. Okay, next we learn about how to integrate the trigonometric function. For example, for sine we have negative cos fx over f prime x. Okay, and also for integration of cos we have sine fx over f prime x. Okay, for example, if we have integrate sine 2 pi x over 3 dx, it will become negative cos 2 pi x over 3 over 2 pi over 3, which is equal to, simplify this one, we get negative 3 over 2 pi cos 2 pi x over 3. Okay, if you don't have limit, just put plus c. Okay, so next we also learn about the sine minus x equal to negative sine x, cos minus x equal to cos x, sine n pi equal to 0, cos n pi equal to negative 1 power n, sine n pi over 2 not equal to 0. And also make sure if you have sine n x, do not equal it to 0 because, if we have sine n x, okay, sine n x, do not equal it to 0 because if x equal to pi, it will become 0. But if x other than integer, positive integer, it does not necessarily to become 0 always. Okay, so for our own sake, we just assume that sine n x not equal to 0 for all value. Okay, so that's all. Thank you.